Okay, so the last we are discussing the last instructions of the our arithmetic instruction. Sorry, that is DAA. DAA, what this do these things do? DAA, it converts. Sorry, it converts the our accumulator. That means the content that is stored in the accumulator, it converts that from hexadecimal to decimal, that it converts from it is basically doing what? It is basically converting the content that is present, it converts that content. Means let's say inside of it hexadecimal content is present, it converts that hexadecimal content to the decimal concept, decimal. So here what will be the addressing mode? Now if you remember, there is no, we have nothing operand mentioned, only like this opcode it is given, and no register is mentioned, no memory is mentioned, no direct immediate addressing is mentioned. Then what will happen? We call that as the implicit addressing mode. We call that as the implicit addressing. So another one is, let's say, HLT command, halt, like NOP, no operation. This all our commands are what? Our implicit. These commands are implicit addressing. We call implicit addressing mode. These commands use, and they are what? They are using the implicit command, and our length will be what? So no numerical value is present for that. So if no numerical value, then length will be what? Then length will be 1. So that is all we have. The instruction which we have, the all the instruction, arithmetic instruction that is present. So this is all about our arithmetic instruction. Now we will move to the logical instruction. The logical instruction which we have, that logical instruction case we will move now. So the first logical instruction, which we have, that is, we are saying that as the ANI. Now ANI and a 8-bit data is mentioned. So ANI means what? And immediate. ANI means and immediate. So ANI and this 8-bit data. So the content which is present in the accumulator will be, with that AND operations will be performed. With the 8-bit data which we mentioned, with that 8-bit data, the content of the accumulator, will be, and with that AND operation should be performed, and the final product will be stored into the accumulator again. So here also I mentioned, that means immediate addressing, and the byte length is what? The byte length is 2. ORI means or immediate. ORI or immediate. That means what will happen? The content that is present in the accumulator, with that the 8-bit data, with that the 8-bit data will be OR, with them perform the OR operation, and that they are performing the OR operation, this will be stored into the accumulator again, and that is what the addressing mode will be, the immediate, and the byte length will be what? 8-bit mentioned, that's why this is byte length will be 2. Then XRI. XRI means what? XOR immediate. XOR immediate. So content of that, we perform the XOR operation with the address, the 8-bit address we mentioned. with that 8-bit address, the content of the accumulator, we are performing XOR operation, and the final product which we get will be stored into the accumulator again. And this is what, this is the immediate addressing mode. And the byte length is what, 8-bit mentioned, so byte length will be 2. Then ANA, and a register name is given. So AND operation, ANA, that means AND operation, normal, there is no immediate operation because here register is mentioned. If 8-bit data is mentioned, that means immediate, then immediate operation should be performed. But here it is what, it is mentioned our register, the register name is mentioned. So if register name is mentioned, that means what we have to do, we have to perform the AND operation with that register. So the general format is that, and if we say the example is ANA and a register name, and the register name is mentioned, this is what the register B, the B register is mentioned. So that means the content of the accumulator and with the content of the B register, both that content we are performing the AND operation, and the final product we are storing into the accumulator again. So register is involved, that's why it is register direct, no numerical value, the length of byte length is 1. Then next is ORA, and a register, that means OR operation, and register, let's say we are given register name as E, or let's say the register name as E. So that means what will happen, the content of the accumulator, with that the content of the accumulator and OR operation, this is what the OR operation with the content of E, because here we are using ORA E. So the content that is of the accumulator with that the content of the E register, both that content we are performing the OR operation, and the final product is stored into the accumulator again. The final product is stored into the accumulator again. So here also this is what, this is the register is involved. The register is involved, that means this will be register direct, and the byte length will be what, the byte length will be 1, no, because no numerical value is there. Then after that XRA, and let's say a register name, we are using the register name as D. So what will happen if it is mentioned XRA and D? Anyone? Can you say, anyone, what will happen? क्या हो सकते हैं अगर XRA ऐसे D मेंशन हुआ? बहुत सिंपल है, ट्राई कर सकते हो कि क्या हो सकते हैं अगर ऐसे मेंशन है XRA और एक रजिस्टर का नाम दिया है D.
So
तो
we are
इसका
performing
फंक्शन,
XOR operation on between D register D and accumulator and stored it in
yes,
accumulator.
yes, that means this will be what, this will be with the accumulator and XOR and D, and it will be stored into the accumulator again. It will be stored into the accumulator again. So what will be the its byte length and addressing mode?
So its byte length is 1 and
Yes,
addressing mode is register direct.
yes, the addressing mode is register direct because here it is register involved. So that's how you will able to do that, because this is very much easy. You have to only do what, only some things you have to keep in mind. Then the instruction is, if the instruction is given, then these things you should keep in mind, then you can functions, what the function it is performing and what addressing mode and what the byte length is, you will only see the command, you will say that, only seeing the command. Then next is what? The next is ANA. Let's say the next instruction is ANA, ANA, and a aim is mentioned. ANA and aim is given. ANA, that means AND operation, and here aim, directly aim is mentioned. So if directly aim is mentioned, that means this will be indirect addressing mode. Like this, if in the command directly aim operation is given, like aim name given, then always know that it will be the indirect addressing mode and no numerical value. So that means it will be, the length will be what? The length will be 1. The length will be 1. And that means what? Here direct aim is mentioned. So if you remember in the our case, we have already discussed in our in arithmetic instruction case, like if this is mentioned aim, that means what we have to do with that, that means what we will perform with that accumulator. With the accumulator, the content of the accumulator, we will perform the AND operation with whom? With the aim. And it is what? It is the indirect addressing mode. That means this is the memory location, and inside this memory location a data is stored, and this memory location is stored by a register, HL register, and we call that as the HL register pair. So HL register pair will hold this memory address, and inside of that memory address there is the content, and with that content we will perform AND operation with the content of the accumulator. So with inside of this content there is content present, and inside of the accumulator there is content present. Both this content we will perform the AND operation. So that's why, and after that where we will store, we will store into the accumulator again. We will store into the accumulator again. So this is the ANA aim functions name. So this is what, this is our ANA, then aim. So let's say the next we perform, it will be easy. Let's say 1 minute. Then next instruction. The next instruction, it is given, let's say ORA ORA and memory given. So what will happen here? What will happen for ORA M? Same as that for and which we have seen. For that, like that, it will happen. So what will happen here? The content with the accumulator will perform OR operation with whom? With the memory. It will be held by the HL register pair, and the final product will be stored by the accumulator. And what will happen? It will be indirect addressing mode, and no numerical value is present. Then that means it will be 1. The length, the byte length will be 1. So this is the next instruction, ORA M. Same as that for XRA, I am not discussing for that. XRA will, you can able to say that what will be the XRA. XRA means what? XOR operation. And XRA, let's say it is given like that. XRA M. So that means what? XOR operations will be performed. In this case, the XOR operations will be performed. So same process, same thing. Like that, we have to perform the XOR operation with the M, and that M will be held by the HL register pair, and the final product will be stored by the our accumulator. The final product which we get will be stored by the accumulator, and that means it will be the indirect addressing mode, and the byte length will be 1. So that is for XRI. Then the next command we have, that is RLC. RLC. Now this is the general format, RLC. And for example also we mentioned like this only, RLC. RLC means what? R means rotate, L means left, C means without carry, means rotate left without carry. It is saying rotate left without carry. So what will be happen? The content of the accumulator will be shifted to left by 1 position. Now what this means? Now our accumulator, let's say this is our accumulator. This accumulator, normally our accumulator is of 8 bits. Our accumulator can store a 8-bit data. So we divide that. This is our accumulator. So let's say 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. Then let's say this we divide like that. So 1, 2, 3, 4, 5, 6, 7, 8. Okay. So this is our total accumulator. Now our accumulator is capable of storing 8-bit data. So from 0, 1, 2, 3, 4, 5, 6, 7. So this is what, from 0 to 7, 8-bit. And there is a carry. There is, other than this, a carry bit is there. Now what is happening here? This is happening that our content of the accumulator will be shifted to left, by the position. So that means, and here it is mentioned without carry, So that means what will happen? The content here will be moved here, 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 and this content will be moved here. And this content will go here also, and this content will go here also. That means carry is lost. You see, carry is lost, because if it is shifted from here, it is the content that is here, it will be shifted left 1 position. So this place become vacant. You see, this place become vacant. So this will go to here, 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 and then this will go to here. So that means this is vacant now, and then this will go where? This, the content that is here present, is go in 2 position. It is going in the carry bit, and it is also going in the vacant position. So this is what, if it is rotate left with carry. So if there is no carry, then this will be happen. But this is the command RLC, rotate left without carry. The next is what? The next we have, that is the our RRC. That means what? RRC? RRC is rotate right without carry. Rotate right without carry. That means same process. Here the same process will happen, but in the right side. So what will happen here? This will be in this case. So if there is RRC, the command is RRC, and here this will happen. So that means this is, let's say, the carry, and our total accumulator is like that. So this here 1, 2, 3, 4, 5, 6, 2, 3, 4, 5, 6, 7, 8. Okay. So like this, let's say our accumulator. So that means right shift here. The content of the accumulator will be shifted right with by one position without carry. So that means this will be moved here. 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 And here another thing, this will be moved here. Then this will be moved here. This will be moved here. This will be moved here. And this will move to the finally again this will move here. So like this, you see here also the carry bit, we are not using the carry bit. The carry bits kept vacant. So that is the for rotate right without carry. And RAL, the next is RAL. This is the rotate left through carry. So that means here the carry will be, we will use the carry. Rotate accumulator left through carry. So the content of the accumulator will be shifted to left by one position through carry. So that means we will now consider the carry here. So that means what will happen? So if we see that, then this will be shifted here, 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 and then this will be shifted here. And this will go where? This will go to the first, the vacant position, which in that case there it will go. That means rotate accumulator left, that through carry. And this will happen, this is for the RAL. And for RAR, that is the right, rotate accumulator right through carry. So here what it will happen? Here the rotation will be what? The rotation will be happen. So that means here also as a carry we will consider. So in the right position it will be shifted and we will consider the carry here. So that means this will be shifted here, this will be shifted here, this will go 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 here, and in this position, instead of this, it will go now to this position for RAR, because here we are considering the accumulator. Here we are considering the shifting. In this case, shifting, we are considering the accumulator. So that's why this will go here. So this will be the rotate accumulator right through carry. Okay, clear till now? It
Yes,
is
sir.
clear? Okay. So this is what? This is the rotate our rotate accumulator right through carry. Then the next, this is what the instruction. The next instruction is CMI. CMI. So CMI means what? CM means compare, immediate. So that means if we say use the I, that means immediate, compare immediate. And what will be there? a 8-bit data. So a 8-bit data. So this is what? This is the general format, CMI and the 8-bit data. So let's say in this we mentioned CMI, and in case of this 8-bit data, let's say we have used named 25H, like this. Like this we mentioned 25H. So that means what? That means the content of the accumulator, with the content of the accumulator, the comparison is doing with whom? This particular data. So comparison, and this is what? This is checking. So comparison will be checked. So let's say what will happen here? Comparison we are performing. So that means this will be minus, because for comparison, let's say this is the 25H. The comparison is going. So comparison means three types of comparison happen, that if this 8-bit data and this the content that is present inside the accumulator both are same, in that case the result will be 0. If the content that is present in the accumulator is greater than this number, then what will happen? We will get a positive value. If the number that is, or the data that is present inside this accumulator is less than this value, this 8-bit data, then our value will be negative. So this is what? This is the CMI or the compare function. Now if it is CMP and a register, that means same thing will happen. Same thing will happen, but the comparison will now between the two register. So the register name you will give with that register content, the with the content of the accumulator, this will be compared. Let's say in this you mention CMP and give a name register B. So that means the content of the accumulator, with that the content of the B will be, with that content of the B will be compared. So we get like this three values. What? If the content in the both content are same, then 0. If the content that is present in the accumulator is greater, then the positive value. And if the content that is what for in the register, the accumulator register, it will be less, then we get the negative value. So by comparison we get like these three values. And what will happen? This is what? This will be our register is mentioned. That means it will be register direct. And this is what? This will be indirect. Sorry, not indirect. This will be immediate, because here I mentioned, that means what? It will be the immediate addressing and immediate addressing mode. So this will be immediate addressing mode. And what will be this? This will be the register, because register is mentioned. So that means it will be the register direct. And what will be the byte length? The byte length will be 1. For this also the byte length will be 1, because sorry, for this the byte length will be 2, because a 8-bit data is mentioned. A 8-bit data, if it is a 8-bit data mentioned, that means what? The byte length will be 2. But here in this case no numerical value is present, so the byte length will be what? The byte length will be 1. And if it is mentioned CMP M. Can anyone tell what will happen? Anyone can try? Then what will happen if we mention this CMPM?
Comparison is performed between memory and accumulator.
Yes, and that memory will be holded by whom?
HL register.
Yes, that will be holded by the HL register pair. And what will be the addressing mode of this?
Indirect.
The addressing mode will be indirect, and byte length?
1.
Yes, the byte length will be 1. So that's how the thing is, that if CMPM it is mentioned, that means the content of the accumulator, with that the comparison will be happened with the content of the memory, and that memory is holded by the HL register pair, and the final product is stored into the our accumulator again, and it will be what? It will be the indirect addressing mode, and this is what? This is indirect addressing, and that will be the our length, byte length will be 1. Then the next is what? The CMA. The next function is CMA. CMA is what? Complement accumulator. CMA means complement accumulator. So the content of the accumulator will be complemented. That means, let's say in the accumulator 0 is stored, then if we use this command CMA, then that means this will be complemented, it will become 1. So complement accumulator, the content of the accumulator will be complemented. Then the next is what? The next function, that is CMC. CMC, that means complement carry, complement the carry. So CMC will happen that the carry will be complemented, complement the carry flag. The carry flag that is present will be complemented. And the last one is what? The last one which we have, that is STC. STC, that is STC. STC means set the carry flag. The carry flag which we have to set that. This is the known as the STC. Okay. So this is all about our logical instruction. All the logical instruction which we have, that logical instruction. So till now, total we have seen the data transfer instructions, all the instructions, then the arithmetic instructions, all instruction, and this is the logical instructions, all instruction. Only one instruction set, that is today we'll not able to discuss that because time is so much less, but that is only left, that is the branching instruction. In this branching instruction we will see the jump instruction, the many types of jumps related to the relating using like carry, related using the 8-bit data. Like this we will see the jump operation. Then the call instruction, call the subroutine, the subroutine instruction, and some machine instruction which we have, that is we will see in the next class. For in tomorrow we will see that. So this is all about today. So if anyone has any question till now, you can ask, or otherwise I will end the session. So this is up to today's class. Okay. So if you see, then almost maximum our 90%, 89-90% syllabus of the computer architecture is completed. Computer architecture, some part which we left, that will be take maximum our classes, not so much classes. This will the some parts I have left. So this will be completed. So you can expect that inside the January your syllabus will be completed. Then we will discuss about the questions format. With that questions format, if the time we get, in that time I will discuss the questions. With this, the questions like this we will discuss. So then today is this much. Then thank you everyone. I am ending the session.
Thank you, sir.
Okay.
Thank you, sir.
Thank you, sir.
Okay.